This is Josh White with JW Math Tutoring. Today's video is going to focus on Digital SAT Math Practice Test 6, Module 2B from the Bluebook app, which is the harder of the 2 second modules from Practice Test 6. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin, this Digital SAT Practice Test 6, Module 2B, the harder of the 2 second math modules. Two things to keep in mind. First, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. And second, because I like to show as many methods as possible to solve these problems, it's very likely this video will go past the allotted amount of time for it. Okay, so just keep in mind the reason I'm most likely taking longer than 35 minutes to solve these 22 questions is because on some of them I'm showing 2 or even 3 different ways to solve them. All right, so going ahead and getting started with question number 1. So in this question, you're basically told that it's starting with 4,500 cups, and you're just taking away 70 per day. How many days will it take till you reach 1,700? So you just have a basic, equation. 4,500 minus 70 times x, where x is the number of days, and that's equal to 1,700. So you can go ahead and solve this. I just subtracted 4,500 over to the other side. You get negative 70x equals negative 2,800, and then you just get x equals 40. Okay, so correct answer is going to be letter B. Note, you could also back solve this one. So just start with answer choice A. Take 70, multiply it by 20 days. Subtract that from 4,500. Does it equal 1,700? No, it doesn't. Move on to answer choice B, and then you'll see that one's correct. So you could also back solve this. You don't actually have to set up the equation. Next, we have a geometry problem. So we have a triangle. We're told the measure of one angle, and we want to know, what could be the measure of the another angle in the triangle. So here's the thing. Basically, if you take all of these answer choices and you add them to 63, 3 of them are going to make more than 180 degrees, which is going to be impossible because we know all 3 angles have to equal 180. Therefore, you cannot have 2 of them either equaling 180 or adding up to 180. So, for example, 63 plus 180, well, it's 243. That's already way past 180. So you get rid of that. You do the same thing with 126 and 63. Let's see, that's going to be 189. Okay, get rid of it. 118 and 63, if you add those up, that's going to be, let's see here, 181. So that's more than 180. So by process of elimination, it has to be A. If you add these two up, you are going to get 179, which makes sense because that's less than 180, and then you'd have 1 degree left over for the third angle. Okay, so correct answer for this one is just going to be letter A. Next up, we have a single linear inequality with 2 variables, and then we've got some tables of values for x and y points, basically, and we want to know which of these are the solutions to this problem. So you could go through and you could plug in, let's say, one of the x values and then compare it to the y values and then see which ones you could keep or which ones you could eliminate. So let's start with 2. All right, I'm going to do 4 times 2 plus 8. So 4 times 2 is 8. 8 plus 8 is 16. Notice that the y value has to be greater than 16. So A, we would keep. B, we would eliminate because 8 is not greater than 16. Cross it out. C, we would eliminate because 13 is not greater than 16. And then scrolling down here for D, again, it's the same thing. 13 is not greater than 16. Okay, so right off the bat, B, C, and D are all out. We don't need to check anything else. We know for a fact that it's going to be, answer choice A. Now, you could also go ahead and you could check this in Desmos. So you could just go ahead and you could graph this inequality. And now, basically, what I would do is I would just type in some of these points, like 2 comma 19. All right, that is a solution, so we would keep A. Let's see, 2 comma 8. Nope, not a solution, not in the shading. 2 comma 13. Nope, not a solution, not in the shading. And then if you scroll down to D, again, 213, we already know that's wrong. All right, so this just confirms that A is the correct answer choice. Next up, question number 4. Here we have a function. It's a linear function, and they want to know where it equals 5. So the thing is, if you want to do this by hand, you would, of course, just set it equal to 5. And what I would do then is I would multiply both sides by 7 just to clear the fractions. So we get 35 equals 9x plus 8. 9x is equal to 27, it should be. X is going to equal 3. Okay, correct answer is going to be 3. Now I will show you, you could also do this in Desmos, probably quicker to be honest. All we have to do is type the equation, and there's two ways you could do this. We could either set it equal to 3, and then it comes back here. Okay, wait, no, sorry, not 3, 5, equal to 5. Okay, and now we click on it, 3, 0, x is 3, that checks. Or alternate method is you could graph basically the left side of the equation and the right side, see where they intersect. They intersect where x equals 3. That just confirms that 3 is the correct answer. Next up, question number 5. Here you have basically just translating some text into an inequality. And the speed of this plane is between 150 miles per hour and 170 miles per hour. So the correct answer for this is just going to be D. Okay, D is showing the speed, which is s, which is basically between, i.e., it's 150 is less than or equal to s, which is the same thing as saying s is greater than or equal to 150. And then at the same time, s is also less than or equal to 170. Okay, so D is the correct answer because D has basically two constraints on it. You know, it's greater than a number, but it's also less than a number. Next question, number 6. Here we have a graph, and they just want to know what's the predicted number of projects at the end of November 2012. So notice that they tell us here that the way this is structured or set up, okay, X represents the months after the end of November 2012. So that means the starting thing right here, this is just the end of November, 2012. So what is the Y value when X is 0? Well, it's just 5. So correct answer for this one is just the y-intercept. It's just 0, 5, and that's it. Next up on 7, we have a linear function. They give you 2 points, essentially. They want to know the equation that defines it. So if you're going to do it by hand, you could just go ahead and find the slope by doing y2 minus y1 over x2, corresponding x value, minus x1. That's going to be positive 7 on top, negative 2 on bottom. So the slope is negative 7 halves. Get rid of A, get rid of B. Now to find the y-intercept requires a little bit more work. We're going to go to y equals mx plus b. We're going to pick one of these points to plug in. Let's see which one I used. I used 2815. So I said 15 equals negative 7 halves times 28 plus b. 2 goes into 28 14 times. Negative 7 times 14 is negative 98 plus b. And hopefully now you recognize that b is going to be 113. So we can get rid of this. Correct answer is letter D. Now, we can do this in Desmos though, and it'll be probably much quicker. So let's type in our points. 28, 15, 26, 22. Let's do a linear regression. All right, our slope is negative 3.5 and our B is 113. So hopefully you recognize negative 3.5 is negative 7 halves. If you did not, you could type this and then just click the little button here and it would tell you it's negative 7 halves. Okay, so that confirms negative 7 halves x plus the B value of 113. Next up, question number 8. Here we have Another linear function, basically we have a table of values, like x and y values, in this case c and p. And the problem is, though, what makes this a little tricky is that the answers are not given in slope-intercept form. They're given basically in kind of like standard form. So there's multiple ways that you could do this. You could go ahead and you could subtract. First I'll show you the straightforward way. So straightforward way would probably be find the slope. Let's do 284 minus 174 over 5 minus 3. Okay. So it looks like it's going to be 2 on the bottom. That's going to be, I believe, 70 on top, which would be, no, it's not going to be 70. It's going to be, what am I saying? 110 on top, not 70. So the slope's going to be 55. Now, the y-intercept, it most likely looks like it's going to be 9. I'm guessing just by looking at the numbers here, but let's just go ahead and double check it. So the slope, hold on, erase that. Slope is 55. Let's use 3 plus b equal to its y value, 174. 174 is equal to 165 plus b. Okay, b equals 9. So we get y equals, or okay, 55 times c, and that's actually not y. It should be p here, because p is what I'm treating as my y, plus 9. So now, if you rearrange this, first of all, notice D and C are out. The 55 is multiplied by the C. It's not multiplied by the P. So get rid of that. Also notice in these answer choices, the C term is positive. That means technically I'm going to bring the P over to the right, and I'm going to move the negative 9 over to the left by subtracting it. So I get 55C minus P equals negative 9. So the correct answer for this one should be letter A here. So again, that's just a straightforward way, to solve it. You plug in, you find the slope, and then you plug in the slope and a point to find the y-intercept. Then you have to do a little extra work to rearrange it, okay, to put it in standard form. Now, alternate method you could use to solve this is to just back solve it. All right. So all you would do is I would say, okay, I'd go through the answer choice and I say 55 times 3 minus 174. Does that equal negative 9? Yes, it checks. Therefore, that one's correct. Now, technically, you would need to check all 3 points before you could conclude that A is the right answer, or you would need to go through the other answer choices and check at least 1 point in them to make sure it does not work. Okay? So, so I guess the easiest way, let's just check all 3 points. It's really not going to take that long. Does that equal negative 9? Yes. And 10, 559. Okay. So all 3 points work in A. Therefore, A has to be the correct answer. Alternate third method you could use to solve this as well is to just go through and basically you could just do the table and do a linear regression. This is just going to cut out the work for the slope and y-intercept, but okay, so you get the slope is 55, you get the y-intercept is 9. So that tells us right away, again, I'm treating my cars or my C as x. So that tells you C and D are out. But now you're down to A versus B. So if you know the y-intercept is 9, basically what you could do is you could plug in 0 for C in each of these. And then notice that in the first one, if you solve for P, you get positive 9. In B, if you then solve for P, you get negative 9, which does not match the B value we're given over here. Okay, so that's a third way you could actually get the equation for this one. Next up, problem number 9. They want to know about a solution to this one. So this one's really asking you to use either completing the square or quadratic formula. I'm going to do quadratic formula because I think most people probably don't remember completing the square, even though this one would probably be quicker to do it. So what I'm going to do is just plug in negative b plus or minus square root of b squared minus 4 times a times c. Extend those over 2 times a. All right. So now we got negative 12, 2, plus or minus. This is 144. This is 160. Together, they equal square root 304. Now this you have to simplify. Basically, it simplifies to 16 times 19. And the fact that there's a bunch of square root 19s, that's a clue, that's a hint how you could know to check that 19 is a factor of 304. So we get negative 12 plus or minus. The root 16 comes out as a 4. Root 19 over 2. And now we just have to cancel everything out by a factor of 2. So we get negative 6 plus or minus 2 root 19. So it's going to be answer choice D. B only has part of it. C, there's no just root 19 on its own. It has a 2 in front of it. A is not negative 6, so that's wrong. It's going to be answer choice D here. I'll just clear the screen so we can see it. Now, alternate method you could use to solve this if you were having trouble is you just go to Desmos, type in the equation. Okay, and you look for your two x-intercepts. All right, so either 2.7 or 718 or negative 14.718. Then I'm just going to run through the answer choices and see. Okay, notice this is negative 2.71, but we want positive. So that's answer choice A, and that's wrong. Now, answer choice B, let's just delete this. Nope, don't have that as an answer. Nope, does not cross at that value. So it's got to be D by process of elimination. And if I type it in, notice here I get the 2.717, which corresponds, it matches with this value. So that confirms letter D. Again, you could do the problem entirely in Desmos. All right, next up, question number 10. Here they want to know the y-coordinate, the y-intercept of this graph. So you could do this one by hand. However, it's so much quicker and so much easier to just go to Desmos, graph it, get the y-intercept value that way, and have your answer. Because you don't have to, get it into slope-intercept form. You can just type in the equation as it is. So here it is. Okay, it's 37.8. Now you can zoom in. As you zoom in, you'll notice that see all of these things have 3 decimals, most of the points, but this one stops at 8. So that tells me it doesn't have any more decimal places after that. It's just exactly 37.8. So you can just type that in. That's your answer. You don't have to do any other work. All right, question number 11. They want to know which linear system represents this one. So a couple things. You could do this in Desmos, very easy, just type in all these answers, see which graph matches. I'll do that in a second. If you wanted to do it by hand, what I would notice is, first of all, both equations have an x-intercept of 8. One equation has a y-intercept of 3.2 approximately, and the other is 4 roughly. So I would just go through some of these and I would look at them and say, okay, answer choice A, first line. What is the x-intercept? So in other words, this is 0, and if you solve for x, the x-intercept is going to be 4. So that doesn't match an x-intercept of 8, which they both have. Eliminate it. Same thing with B. Make this 0. The x-intercept is going to be 4. That doesn't match the graph. Get rid of this. Okay? Now, C, the x-intercept is going to be 8 for both, so that part works. But notice, if I check the y-intercept, meaning plug in 0 for x, for C it comes out to negative 3.2. For D it comes out to positive 3.2. So therefore, we can cross out C. We already know by process of elimination it's going to be letter D. Okay? So you don't need to spend the time going through and actually solving this out and seeing which of these, solve all 4 of these and see which one has a solution at, 8, 0. we can just go through and look for the x-intercepts and match characteristics of the y-intercepts, and know that the answer is going to be letter D here. Now, I will show you, though, that you can also do this in Desmos. So it might take a little time, but it's actually not going to be too bad because a lot of the equations are similar. All right, so let me just zoom back here. So, okay, these obviously do not match. So A is out. Now I want to check B. Does this look like the picture on the screen? Nope, absolutely not. So now let's look at C. 4x minus 10y, and we want to do negative 8x plus 10y. It's still negative 64. Okay, does this look like what's on the screen? No. So it's going to be D, but just by process of elimination. All right, now it's looking a little closer. Okay, now this picture looks very, very similar, basically identical to what we have on the screen. Okay, so that's how you can do this in Desmos. Really doesn't take, that long. Next up, question number 12. Here you have a system of equations, and they want to know the value of 6 times x minus 2. So the quickest way to do this is just add the two equations together. This column will cancel out. You'll get 2 times x minus 2 equal to 559. Then you technically multiply that by 3, and you get 6 times x minus 2 equals 16. Where's the answer here? 77. So that is the correct answer. That's what we're going to plug in here. Now, a couple things. Even if you did not, even if you didn't see to do that, if you just, once you added them, went to go ahead and solve it out, you would just end up getting x minus 2 equals, dividing them by 2, where is it here? It's 279.5, and then you add 2, so you get 281.5, and then you just multiply that basically by 6, and of course you subtract the 2 from it, and you're just going to get the same answer. Okay, so however you solve it, it's the same value. Of course, you could also do this one in Desmos. So, for example, you would just plug in both equations, and then you're going to look for the solution. Okay, now you're going to have to zoom out a ways here. Okay, so here's the solution point. So again, the solution point is 281.5. So we want 6 times 281.5 minus 2, 1677. That's our answer. Again, that's how you could do it entirely in Desmos. Next up, what's the minimum value of this function? So shorthand way to do it would be to use the formula negative b over 2a. That's the x-coordinate of your vertex for this quadratic function. So that would be the opposite of negative 48 over 2 times 1. 48 over 2, which is 24. Then you have to take 24 and you have to plug it back into the function. So in other words, you got to do 24 squared minus 48 times 24 plus 2304. Blah, blah, blah. You go ahead, you calculate it all out. It's going to be 1728. So that's the minimum value of the function, basically the y coordinate of the vertex. Of course, it's so much quicker and easier to just go to Desmos, type in the function, zoom way out here. Yeah, see, it's way up there, but the minimum value, the minimum thing is highlighted. Here we want the y coordinate because we want the minimum value, which is always the y or the output. So 1728, that's how we get it. And we can move on to the next problem. All right, now for this one, this is actually a little tricky. The answer to this is going to be letter B. Okay, this actually has one solution. And the reason why is because if you try to solve this, well, if you actually do solve it, okay, if you would add 49x to both sides, it's 49x, you get 0 equals negative 49x, and then you would divide by negative 49, but 0 divided by anything is just 0. So there is one solution to this problem. It's just x equals 0. Now, the thing is, though, if you go to Desmos, you could just type it in, and you could see that there's a vertical line here on 0. So you just recognize, okay, there is one vertical line, so there is one solution. Or if you do the method that I like to do, which is y equals left side, y equals right side, again, it's kind of difficult to see both of the lines. You have to kind of like zoom in because they're both really steep lines. But they intersect at 0, 0 because if you click here, you can see that there's an intersection point. So again, there's one solution. They don't ask for the value, they just ask how many there are. So correct answer is letter B. All right, next up, question 15. Here you have a problem with a function, and they want to know the value of g of 7 minus whatever, equals 0. What's the w value? What's the sum of all the possible values of w? So I guess I would say the traditional way to do this is to notice that your three solutions for x, when this thing's equal to 0, are going to be 0, positive 2, because you said x minus 2 equal to 0, and just add 2, and negative 6. Okay, you said x plus 6 squared equal to 0, square root both sides, still get x plus 6 equals 0 and negative 6. So then really what we're saying is 7 minus w equals 0, 7 minus w equals 2, and 7 minus w equals negative 6. So when you solve each of these equations for w, you get 7. Here we add w to the right and we subtract 2 and we get w equals 5. Here we add w to the right and we add 6 and we get w equals 13. So 7 plus 5 is 12 plus 13. Correct answer is going to be 25. Okay? Now, I will show you something you can do in Desmos, which will make this potentially a little easier to solve. So I'm going to start off and define the original function, just type it in as it is provided. Okay, so here's the original function. You can see it's like whatever, it's for there. It's got two little, local min values. All right, then I'm going to define a new function, which is basically the translation that's provided there. Okay, now notice if I take off the original, this new function here, basically where it is 0, those are the three values I want. Those are the three values I'm going to add together to get my sum. So notice 13, 7, and 5. Just add those together, and that's it. 5 plus 7 plus 13, 25. You can get your answer in Desmos in, under 30 seconds. All right, next up, number 16. So this is a probability question. It's kind of challenging because of the fact that you have to account for these multiple rows. Okay, so there's 6 rows of birch trees, 5 rows of maple. Each row of birch trees has 8 trees 20 feet or taller, 6 trees shorter than 20 feet. Blah, blah, blah. Same thing, maple, there's so many taller, so many shorter, blah, blah. Okay. A tree from a row is selected at random. What's the probability of selecting maple given the tree is 20 feet or taller? So the first thing we need to do is figure out how many total trees 20 feet or taller are there. So we know that each row of birch trees has 8 20 feet or taller. So there's 8 in one row, but there are 6 total rows. So there are a total of 48 birch, which are greater than 20 feet. Doing the same thing for maple, we have 9 total trees in one row. So 9 in one row. And then there are times 5 rows, 45 total maple, greater than 20 feet tall. So the total number of trees greater than 20 feet is going to be 48 plus 45, which is 93. So that's going to be the denominator. That's the number of trees we can choose from because it tells us given that the tree is 20 feet or taller. So what's the probability of selecting maple? Well, there's 45 maples that are 20 feet or taller out of the 93 total. So this is the correct answer. You could technically enter it in like this, or it also just reduces to 15 over 31. So the correct answer for this one is just letter C. Next up, question number 17. Here you have a problem where you have a circle and you have a rectangle inscribed in the circle. Ignore the chord drawing. Okay, they tell us that the diagonal of this rectangle is twice the length of the shortest side. So let's say this side is x, let's say this side is twice that, which is 2x. Notice this diagonal is technically also a diameter of the circle. We'll come back to that later. We know the area of this rectangle is this value. What is the length of the diameter? The whole key to this problem is recognizing that, like, say I just call this y, okay, this length here. X squared plus y squared equals 2x quantity squared using Pythagorean theorem. So if you solve for y squared, you just get 4x squared minus x squared, or 3x squared. And then if you square root it, you get square root of 3x squared, which is just square root of 3x. You know, the square root of x squared just simplifies to x. So this side down here is actually root 3x. Technically, in this example, it also forms a 30, 60, 90 right triangle. So now what we can do is we can find the area, which is just area for rectangle, which is just length times width. That's going to be x times root 3x, and that's equal to 1089 root 3. So notice now the root 3's can be canceled out. You can just divide both sides by root 3 and they cancel. So we get x squared equal to 1089. You square root that, x is going to be equal to 33. Therefore, the diagonal is 2 times x. So this diagonal would be 66. That is equal to the diameter of the circle. So the correct answer to this question is just 66. Okay. It takes a fair amount of work, you know, using Pythagorean theorem and then using the area formula, and then just taking your value, multiplying it by 2. But correct answer to this one, again, is 66. Next up, we have a problem with percentages. So for this one, if you want to do it theoretically, basically the way it's going to work out is you would say, okay, A is 22.41%. Okay, so if you convert that to a decimal, it's 22.41 because you divide by 100, move it 2 places to the left. The sum of B plus C. Okay, and we also know that B equals 83%, 0.83 of C. What percent of B is A? So we need an equation that relates A and B together. The way we can do that is we can solve this equation for C. Basically, you divide both sides by 0.83. So C ends up being B divided by 0.83. Or if you just do 1 over 0.83, it becomes 1.205b. And then you substitute this into this original equation here. A equals 22.41 times B plus 1.205b. 22.41 times 2.205b. And now you go ahead and you can multiply this out. And we end up with, let me just confirm here, it should be A equals 49.41b. And notice, okay, what percent of B is A? Okay, so A is technically this percentage of B because it's multiplied by B. So you convert this to a percentage by multiplying by 100%. Correct answer is 49.41%. Okay, it is letter D. Now, a couple things here. Let me just go to the calculator, just make sure I'm reading my notes correctly. 22.41 times 2.205. Yep, 49.41405, you know, whatever. Just going to round off to 49.41%. Okay. Now, you could also do this by actually picking numbers and picking values and like plugging them in. So what I mean by that is, but basically I'm going to pick numbers for B and C, and then based on that, I'm going to find the value of A, and then Based on what I know A is and what I know B is, I will find the percent of B that A is. All right, so slide this over. Okay, first I'm going to define a couple things. I'm going to start with C being 100, and then I'm going to define B as 83% of C. Okay, so that just means that B is 83. Next, I know that A is equal to the sum of, 2241% of B plus C. All right, so far what I've determined is if I choose 100 for C, that makes B 83 and that makes A 4101.03. We could just, whatever, probably round it off to 4101. All right, so now what percent of B is A? So you can actually just type, X percent of B is A. The problem is, notice these answers are going, gigantic numbers. So what you're going to have to do is basically like scroll way out here and you can see it's 4941. So what percent of B is A? Well, 41%. You could also have done basically like just use X, B equals A. And then notice, let me just zoom back in here and zoom out a little. If you do it this way, it gives you the decimal value, which is 49.41. Then you just have to remember to convert it to a percentage. Multiply by 100, move the decimal over twice, and you get the same answer, 49.41%. So this is how you could do the problem by using picking numbers. And again, you can do the entire thing in Desmos, just going step by step by step. Next up, we have question number 19. So this is a problem that you technically can do in Desmos, but because it's a student-produced response, it will take you longer than it otherwise would, if it was a multiple choice, because you don't know sometimes with these, if it turns out to be a decimal, you don't know exactly how far you have to drill down into the decimal places in order to make the two lines exactly parallel. So I'm going to do this one by hand, and then I'll just graph it in Desmos to confirm that our answer is correct, but I would recommend using just solving this by hand as the preferred method. So what I'm going to do is take the first equation and I'm going to multiply by 8. Now, the reason I'm not multiplying by 56 is just to keep the numbers a bit smaller, and the fact that I don't need to cancel the fraction out on the number term here. Okay, the only terms I'm interested in canceling the fractions out are anything with an x or a y. The numbers themselves are irrelevant because when we're looking at no solution, we're just concerned with having the same slope and different y-intercept values, which is already the y-intercept part we don't have to worry about because the p is multiplied by the y here, so the p is really only going to affect the slope. All right, so now when I do that, I'm going to get 7y minus 5x equals 32 over 7 minus 7y. All right, and now I'm going to go ahead, I'm going to add 5x, I'm going to add 7y. So I get 14y equals 5x. Let's just see here. Plus 32 over 7, and then you divide by 14. Technically, you divide this by 14. You can actually reduce this. So here, let's just go to Desmos and just, get it that way rather than, I mean, 32 and 14 would have a common factor of 2, but the 14 is going to multiply by the 7. Okay, so whatever, it's 16 over 49. Okay, so the first one we get y equals 5 over 14, or 5x over 14 plus 16 over 49. All right, now for the second one, I'm just going to multiply everything by 4. That's going to give me 5x plus 7 equals 4py plus 15. I'm going to move the 15 over. I'm going to get 4py equals 5x minus 8, and then divide by 4p. All right, so now for the second equation, I have y equals 5x and divided by 4p minus, it's technically 2 over p because the 8 over 4 becomes 2 over 1, and you still have a p on the bottom in the denominator. So now all we have to do is set these two slopes equal to each other because we want two parallel lines that don't intersect. So 5 over 14 slope from the top line equals 5 over 4p. You can cross multiply this, but if you also notice, since they have the same number on top, then you can just technically set the bottom equal to each other. But if you want to cross multiply it, let's just do it that way. It's 20p equals 70. P equals 70 over 20. So you could write your answer in like that. I'm just going to divide it by 10 and turn it into 7 over 2. So the correct answer is 7/2 or 3.5. So I'm just going to type in 3.5 here. Now in Desmos, again, you could do this, but the thing is it's really difficult to say if the two lines are exactly parallel when they have, like, depending on the value for p that you have. So meaning if I enter, like, the 3.5 in, yes, they're obviously going to look parallel because they are. But the point is if I entered in, if you're just doing this as a free response question with no multiple choice answers, if you enter in 3.49 or 3.51, it's really difficult to look at that and determine that those answers technically are not correct, that the two lines will intersect with those values of p. Y plus 15 over 4. Okay, so here, now let's zoom in. Yeah, okay, so you can see the lines are clearly parallel. But like I said, if I make this 3.51, so again, here we know the lines are parallel. If I make it 3.51, notice there's virtually no change to the graph, okay? Even though technically the lines will intersect at some point, far out here, but by the time I zoom out, it's difficult to see where exactly it is. You basically have to go across the graph and trace here and, who knows where it is or what the value is. Where they're going to intersect. Those are just X and Y here. It looks like it's down here, -880 point whatever. So that's why I would recommend solving this with my hand, and you can use Desmos just to check the answer to make sure that it is correct. Next up, question number 20. This one, there is actually a very quick and easy way to do entirely in Desmos. I will show you that first because it is so quick and so easy. Then I'll show you how you could actually do it by hand. So what I'm going to do in Desmos is I'm going to put in the 3 points that were given, okay? Enter them into a table. All right, then I'm going to do a regression for this g of x function, okay? And it tells us that f of x is a linear function. So on the top of my, in the numerator, on the top of my overall function here, I'm just going to put mx1 plus b because that's what a linear function looks like. Then on the bottom, of course, we'll put the x plus 3 that were given. Let me just zoom in here. Okay, here's the graph of it, but we don't care about the graph. All we care about is what is the y-intercept of f of x? And f of x is this part, represented right here. Well, the b value is 36. Correct answer is letter A, 0.36. That's the entire problem. Done in, I don't know, was that 20 seconds, 25 seconds maybe? And you can move on to the next question. Now, here's how you would actually do it out by hand, though. Basically, what you have to recognize is if you basically cross multiply both sides, that g of x times x plus 3 is equal to the f of x, or the y value for this new function. So if I make a new table over here, okay, this f of x column is going to be equal to the g of x column, which is already given, times the x value plus 3. So in other words, for this first one, it's going to be 3 times -27 plus 3. So -27 plus 3 is -24. -24 times 3 is -72. Here, it's going to be 0 times -9 plus 3. Well, that's just 0. And then for this one, it's going to be 5 times 21 plus 3. Basically, it's 5 times 24, which is 120. So now you have these 3 points. You can go ahead and you can get the equation, the slope and y-intercept, or really the equation of the line. You could do this in Desmos. You could do it by hand. Just to save time, again, I'll just review how to do it in Desmos because there's no real reason to do it by hand when you can just type it in here. So you can type in any 2 of these points. You could type in all 3 of them. It doesn't really matter. Actually, sorry, I'm not typing that incorrect. It's negative 27 is the x value. That goes with the negative 72. And negative 9 is the x value that goes with 0. And 21 is the x value that goes with 120. It's just covered up by the writing. And let's do a linear regression. And we should get the same thing we did when I used the Desmos method originally. The slope of this line is 4. Y-intercept value is positive 36. So same answer, just doing the workout by hand. Answer is still 0.36. Next up, we have one of the most difficult questions on this exam. However, the thing that makes this difficult is basically being able to visualize or set up the picture of what's going on. Like if you can set it up correctly, the actual solving of it is not that complicated. So you have a circle here. You have its center here at G. You have tangent points at M and N. Here's N, here's M. So I'm just going to draw a line out to these tangent points. And then you also have these tangent points intersecting outside the circle somewhere. We'll call it up here, point H. So now I'm just going to draw the tangent line from H and then intersecting at N and intersecting at M. Okay, so this is just a rough sketch of what the picture looks like. 2 things you need to know from geometry in order to solve this. First, the radius of a circle drawn to the point of tangency forms a right angle, i.e. a tangent line is perpendicular to the radius of a circle. So this is a right angle, this is a right angle. Second, tangent lines, that intersect outside of a circle at one point are equidistant from that point to the point of tangency. What I mean is HM is the same distance, that line segment, as HN. So where that helps you is because you know the radius is 168, so this is 168, this is 168, you know the total perimeter is 3856. So the total perimeter is all 4 sides, right? So subtract away one radius, subtract away another radius. If you do that, what you're left with is 3520. And then you divide that in 2 because HM and HN are the same. So when you do that, you get 1760 for this side and 1760 for this side. Now, we just draw this line down the middle, and basically you have 2 congruent right triangles. Okay, but we just need GH, which is the hypotenuse of either right triangle, either the one on the left or the one on the right. So really all you're doing here is now Pythagorean theorem, 168 squared plus 1760 squared equals c squared. It's going to be, let's see, whatever, some gigantic number, 3125824 is what you should get. And then if you square root that, c is going to be 1768. Note if you look at the answer choices, if you can set up the problem correctly and get to this point, you technically don't even need to solve for the hypotenuse because the hypotenuse in a right triangle is always the longest side, okay? 1760 is one side of the triangle and that's a leg. So therefore the hypotenuse must be greater than, in other words, GH has to be greater than 1760. There's only one answer choice that's greater than that, which is, right here, letter D. So you technically don't even need to solve for it if you can set up the picture and get everything to look, correctly. But correct answer is, again, letter D, 1768. All right, for number 22, here we have a quadratic function, and we know 2 of its x-intercepts. We know some information about a, and I want to know which of the following could be the value of a plus b. So first I will show you the method to solve this by hand, then I will show you how you could solve this in Desmos. So to solve this by hand, what you have to keep in mind is the fact that the h value or the x coordinate of the vertex is also equal to negative b over 2a. So how do we use this? Well, if these points are both x-intercepts, they both have the same y value, which is 0, and that means that the vertex is going to be directly in the middle between them. In other words, I can add these two together and divide by 2 to find essentially what the midpoint of them is. And that's just going to be 4 over 2, which is 2. So that means that the vertex is going to be at 2 comma something. I don't care what the k value is. I only care about what the x coordinate or the h value is. So that means 2 is equal to negative b over 2a, or if you cross multiply this, 4a is equal to negative b. So now we could also, and let me just divide by negative 1. Let me just turn it into this, b equals negative 4a, okay? So now we say, okay, what could a plus b be equal to? Well, notice I already said that b is equal to negative 4a. So I can just replace that substituted in. So a plus b is really equal to the same thing as negative 3a. So now you can just start with any integer greater than 1 and plug it in and see which of these values you get. You know, negative 3 times 2 is negative 6. Is that an answer? Yep. And if you go higher, you'll see, well, negative 9, you know, you go up to 4, it's negative 12. Like those, nothing else is going to be there. Okay, so the correct answer here is going to be letter A. Now, here's how you could do it in Desmos. So what I'm going to do is I'm going to make a table. I'm going to put my 2 points in, positive 7 and negative 3. Okay. I'm also going to just start with a equals 2. And then I'm going to do a quadratic regression. You have to define a, or you have to plug in a number for a in the regression statement either way, because if you only have 2 points, otherwise it's not going to work. It's not going to give you it's not going to work out correctly. So now you could check what's a plus b. Is it negative? It's negative 6. Okay, that confirms that a is the correct answer. And then if you want to, you could also move it to 3 and see it's negative 9. Okay, not there. You know what I mean? Move it to 4. Okay, negative 12, not there. But this is how you could do it, you know, again, entirely in Desmos. All right, so that was practice test 6, module 2B of the math part. Probably the hardest single section from all 6 of the Bluebook practice tests, in my opinion. I mean, definitely, if it's not the hardest, I mean, definitely, you know, one of the 2 or 3 hardest math modules. So if you have any questions or comments about this, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. And lastly, check out the videos on Module 1 from the same practice test 6 and Module 2A as well.